we're going to use the product of our previous reaction and reduce it using sodium borohydride. We're starting with 2.2 grams of the product, which is a 2-nitropropane derivative of vanillin. First we'll prepare the batch of solvent that we'll use throughout the reaction. First of all, measure out 10 ml of ethanol. Then add this to a small flask. Next measure out 40 ml of ethyl acetate. This has a habit of sucking up water, so make sure yours is fairly dry. Add this to the flask containing the ethanol. Using a dropper, use the solvent to make a solution of the starting material. You want a saturated solution, so slowly keep adding until everything has dissolved. Not quite yet? Okay, we're there. This took around 10 ml of solvent to dissolve completely. Now measure out 20 ml of the mixed solvent. We'll use this for performing the reaction in. Add this to a 100 ml flask equipped with a magnetic stir bar. Now for our reducing agent. Measure out 1.5 grams of sodium borohydride. We know this is hard to obtain. If you can't get it, then it is apparently possible to perform this same reduction using tin chloride. Worth looking into. Add the borohydride to the solvent in the flask. The yellow color appeared, as you can see, but we're not sure why. Possibly dirty glass or solvent is to blame. Once added, set up the flask with a big condenser and on a cold water bath. You'll want the temperature throughout the reaction to be below 20 degrees C. Get stirring going in the flask, and give a few minutes for the temperature in the flask to equalize with the water bath. We're not actually going to heat the mixture, so you might ask why bother with the condenser. The reason is because when borohydride reacts, it gives off a lot of bubbles of hydrogen gas. These have the ability to vaporize a lot of solvent and carry it out of the reaction flask. So the condenser and cold water circulation minimizes this as much as possible. Now take a small amount of the solution of our starting material and add it through the top of the condenser. Go slow to start with because the reaction can sometimes be very vigorous. The red color is produced and you can see bubbling as the reaction takes place. Keep the addition going slowly. The white precipitate you can see is decomposition products of the borohydride as it reacts. Total addition should take around 30 minutes to complete. After this, leave the mixture stirring for another 15 minutes. Here's what it looks like at the end of addition. Your condenser probably still contains a bit of starting material and evaporated crystals. So use a small amount of solvent to wash the container, and add this to the condenser. And wash the condenser down with a small amount of solvent as well. Once the mixture has stirred for a while, disconnect the condenser. We used a small amount of solvent just to make sure any starting material on the sides of the flask made it into solution as well. Now measure out 30 ml of cold water. First add a small amount of water to the flask cautiously. The mixture will bubble, and then after a few minutes add the remainder of the water to the flask. There shouldn't be any real temperature increase. Leave this to stir for 10 minutes and you'll notice that the red color starts to fade and is replaced with an orange-yellow. A white precipitate of borohydride decomposition products is also visible at the bottom. And you can see two layers, a bottom aqueous and a top ethyl acetate layer. Once the mixture has mostly stopped bubbling, pour this into a separating funnel. Allow the layers to separate. The precipitate will sink to the bottom of the funnel, but this is okay. It's fine, so it shouldn't block anything. Now drain off and separate the bottom layer including the precipitate. Measure out 30 ml of cold water and add this to the ethyl acetate layer remaining in the separating funnel. Give the mixture a shake, and then allow the layers to separate. And then separate off the bottom aqueous layer, adding it to the previous aqueous layer we removed. So now we've got an ethyl acetate solution of our product in the funnel, and an aqueous residue. Prepare a small flask for storing the organic layer, and empty the funnel into this. There may still be some product trapped in the aqueous residue, so we're going to do a quick extraction of this. Pour the aqueous residue and precipitate back into the separating funnel. Measure out 10 ml of ethyl acetate, and add this to the separating funnel to extract any product remaining. Shake again, then allow the layers to separate. Remove the bottom aqueous layer. Now transfer the rest of the ethyl acetate solution from the flask into the separating funnel so that all our product and ethyl acetate is in the funnel. Measure out 20 ml of water and add this to the funnel with the ethyl acetate. Now we need to remove any borohydride remaining, so to do this we use dilute acetic acid. Ours is around 20% concentrated. Add a few drops to the funnel. You might see a small amount of bubbling but not much. You can also use some of the acetic acid to decompose any unreacted borohydride in the aqueous residue before flushing it down the drain. This is safer than risking a hydrogen build-up in a pipe or underground. Drain off the water and acetic acid layer from the funnel, and then collect the ethyl acetate solution which contains our product. Dry the ethyl acetate solution by adding a small amount of anhydrous magnesium sulfate. Just a little should work fine. And then decant the liquid into a weighed 100 ml flask. Weighing the empty flask will make it much easier to determine how much product we have. Now set up for distillation to remove the ethyl acetate. We're using an oil bath for this. We had a glassware breakage, so we're improvising with the collection container without ground glass. The solvent starts to boil off at around 80 degrees C. Using the oil bath means we've got good control of the temperature and can make sure we've got all the solvent off. A small amount of yellow oil remained in the flask. And here's our product, the reduced phenyl to nitropropane. By weighing the flask and subtracting the empty weight we could see we had 1.3 grams of the product. This is a 59% yield, which is a bit lower than expected. We think we probably lost product in the acetic acid washing stage, and next time we'll use salt water to try to reduce loss. It's also a small scale, so some mechanical loss is inevitable.